Hi, my name is Daniel Hickox-Young, and the class I'm presenting is an Introduction to Materials Science. This is designed as a semester-long intro-level college course. My main goal with this course is to encourage students to see how materials science impacts their daily lives, while also helping them build the skills to see themselves as material scientists. By the end of the class, students should be able to do the following: recognize and classify common material structure types, calculate the response of a material to external perturbation, assess whether a material is appropriate for an application, and understand the impact of material selection in their daily lives and our broader society. One of the tools used to achieve these objectives is the materials paradigm, which is a framework for studying the different aspects of materials innovation. On one end of the spectrum, we have processing, or how a material is made, with an example being the molten metal here being heated to high temperatures before being cast in a mold. The processing of a material determines its structure. We can look at structure at a variety of length scales, but an example shown here is of the nanoscale arrangement of atoms in a crystal structure. The structure and composition of a material give rise to certain properties, telling us how a material responds to perturbation. The example shown here is a tensile strength test, which is a measurement of mechanical properties. And finally, these properties define how well a material performs at a given function. This is perhaps the most important part of the paradigm, because this is where we see how the material impacts our lives. It's also challenging because there are many dimensions of performance. For example, this image here shows a steel girder failing on Lakeshore Drive. To perform well, a girder should be strong and tough, but also resistant to corrosion. Beyond the application-specific performance, we can also measure broader impacts of a material's performance, such as its impact on the environment. Is it recyclable? Each of these components builds on the others, and understanding the relationship between them is the work of a material scientist. Students gain experience working with the materials paradigm throughout the course, but the connection is most evident in their final project on materials selection and design. The project takes place over the final 5 weeks of this semester-long course, with class time dedicated to project work and presentations during the last 3 weeks. Students work in groups assigned by the instructor, and the project is scaffolded, with different components of the project being turned in stages over the 5 weeks, receiving feedback on each component before they're combined in a final report and presentation. To successfully complete the project, students will first choose an engineering context where materials selection is important. This could be, say, the thermally insulating ceramics on a spaceship, or the carbon fiber in youth baseball bats, or really whatever context a group is most excited about, pending approval from the instructor. Students then research the currently used materials, examining them using all the lenses of the materials paradigm. What dimensions of most in this context? How do existing materials perform? What properties enable the performance of those materials, etc., etc. Finally, after developing a thorough understanding of the existing material, students will outline a proposal for the design of a new material, again using the materials paradigm. How can the properties be improved? What changes to existing structures might lead to these improved properties? And more questions along these lines. At the end of this project, students will have worked in teams to address every aspect of the materials paradigm, both for an existing material and for one they invent themselves. Performing this project will allow them to practice each of the course objectives, and all within a real-world context of their choice. While many aspects of this course work together to realize the course objectives, I really see this final project as the integration of the objectives, allowing students to literally practice the work of a materials scientist, which, again, was my main objective in designing this course. At this point, I'd like to acknowledge the sources I used for some of these images, and thank you for your attention.